Okay, so here we are at our whiteboard with our coin flips, and so we're going to look at when we flip coin 1. How often did I say we got heads?
You said 20%.
20%, and how often tails?
80.
80, okay. And coin 2 is the same, right?
Yeah.
So if I flip one and I flip the other one, we should be able to figure out how often I get 2 heads, a tail and a head and a tail and 2 tails.
Yeah.
Right? Okay, so coin 1 flips heads 20% of the time, coin 2 flips heads 20% of the time. So since those are independent from each other, we can just multiply 20% times 20% to see how often that happens.
Yep.
Now, we haven't really talked about percents, but you have. Do you know what 20% times 20% is?
It's 40 over 200. Wait. 20 over 100
Yeah,
times 20 over 100.
right.
400 over 10,000.
Right. So 400 over 10,000. That's certainly one way to look at it. Is there a better fraction that we could use for 20% rather than 20 over 100?
Well, we can use 1/5.
We could use 1/5, and even making the multiplying easier, actually 2 over 10 makes the multiplying a little easier.
Yeah.
Do you see why 1/5 is 2 over 10, by the way?
Yeah, because you multiply each side by 2.
Yeah, good job. High five. Okay. So what is 2 over 10 times 2 over 10?
It's 4 over 100.
So what percent is 4 over 100?
It's 4%.
4%. So 4% of the time we should get 2 heads.
You can see that just by taking off 2 zeros here.
Yeah, exactly right. Now what about a tail and a head? That would be 80% times 20%.
But it's 4/5 times 1/5.
80% times 20%. Yeah, and right, it is 4/5 times 1/5.
Or 8/10 times 2/10.
Yeah, 8/10 times 2/10 is actually a really helpful way to think about it.
So we get 16/100.
Okay, and what is that as a percent?
16%.
16%. Okay.
It's
Now,
the
now for heads and tails. We get heads is 20%,
Yeah.
tails is 80%.
Yeah, shouldn't we get the same thing?
Same
We
thing
do get
because
the
it's
same thing.
commutative.
16%. And then finally tails and tails should be 8 over 10 times 8 over 10.
That's going to be 64%.
8 over 10 times 8 over 10. Which is, what is 8 over 10 times 8 over 10? Do you know?
It's 64 over 100.
Very good. Which is 64%. Now, this hopefully is going to add up, by the way, to what? What should these percents add up to? 100%, right?
Yeah.
Why is that?
Because because all percents have to add up to 100%.
Well, those are all the choices, and then all of it should add up to 100%. And the interesting thing here, and the great observation that's pointed out in this guy Jeremy's blog, is that these two probabilities are the same.
Yeah.
So every time I end up in one of these buckets, I should end up in those about the same amount of times, right?
Yeah.
And so all we're going to do is when we end up in one of these buckets with heads and tails, with the coins being different,
Yep.
whatever they are, we're going to take coin 1. Okay? So if I get a tail and a head, we're going to, our secret flip is going to be a tail. When I get a head and a tail, our secret flip is going to be a head. When I get 2 heads or 2 tails, I'm just going to ignore it, okay?
Yeah.
And so you can see about 32% of the time, 16%, we should actually get a good flip.
Yeah.
Okay? So now, we could go do this with coins a bunch of times.
That would take a long time.
That would take a long time, but instead we're going to do it with a fun little computer program on Khan Academy, okay?
Yeah.
All right, you guys see kind of generally what the idea is here?
Yeah.
Yeah.
It's actually pretty neat. I'm actually very excited to see how this works. All right, let's go write our program. And
Yeah.
then we'll talk about it on video. We won't write it on video. We'll talk about it, okay?
Yeah.
Alright.